Welcome to Knowledge Share channel. In this video, we will be discussing about JK flip-flop. In previous video, we have discussed about SR flip-flop, and as you all know, what is a flip-flop actually? Flip-flop is actually a memory element. Okay, so it can store bits. If you see any RAM or ROM, the basic fundamental thing is flip-flop. So flip-flop is the one which is going to store the binary data, that is ones and zeros. Okay, so we have various types of flip-flop. Okay, so each and every flip-flop is having its own plus and minus, and but the thing is, from SR flip-flop this JK flip-flop has been derived, because there is a small drawback in SR flip-flop, like it is having indeterminate state. Okay, so because of which it is not suitable for certain applications of memory storage. So hence we are going for the next version of the flip-flop, which is called as the JK flip-flop. And again here I am going to describe about the clocked JK flip-flop. So in the sense, clocked means it will be having additionally one clock pulse will be there. Only when the clock pulse, so it is a positive edge triggered detector circuit actually. So here you can see this is nothing but an SR flip-flop, is it right? So this is nothing but an SR flip-flop. See here one NAND gate and two NAND gates are there, and these two NAND gates are connected like this. So this is and again one of the input of the NAND gate is given through another NAND gate, is it right? So here, so this is nothing but an SR flip-flop, and this SR flip-flop is again given with one more AND gate. So it is the feedback is taken from the Q bar and it is given as input to one AND gate, and the feedback of Q is taken and it is given as another AND gate, and the output of the other input of the AND gate is nothing but J and K, and you can see that the output of AND gate is given as S and R inputs of the JK flip-flop. So this is called as JK flip-flop. Okay, so J and K are nothing but can be 1 or 0, and based on 1 and 0 this Q and Q bar will change its states. So this is what is given in the truth table. So here you can see that when 0, for example, if Qn is 0 and if J and K is 0 0, you will be having the Qn plus 1 as 0 itself. And if I make Qn as 0 and J and K as 0 and 1, okay, if I give 0 and 1, since J is equivalent to set actually and K is actually equivalent to reset. So here you can see that when J is 0, so Qn plus 1, that is the next state, will be equal to 0. Okay, so you can see that here in the next two states you can see that Qn is 0 0, whereas J is 1 and 1, K is 0 and 1. So here from this you can see that when J is 1 and 1, whatever may be the state of K, that is even if it is 0 or 1, the output Qn plus 1 is 1 and 1. Is it clear? So here next is if what happens. So these four states describes how this Qn, where Qn plus 1 is received when Qn is completely 0. So next we will be discussing about what happens when Qn is 1 actually. What happens when Qn is 1? So here you can see that so there are four different states again. So here when J and K both are 0. So since so now you can see that Qn is 1, is it right? So here both are 0 means it has to go to the whatever the previous state is there, the same state will be retained, that is the 1 itself will be there. For example, if you give 0 and 1, then what is going to happen? So 0 and 1, so now we can see that K is 1, so we have to reset. So whatever may be Qn, it has to go to 0, so it will go to 0. So again next is 1 and 1, so you can see that here Qn is 1. So now we can see that there is J and K. So here you can see that J and K, so 1 and 0. So you will be having Qn plus 1 as 1, because here I am going to that is since K is 0, so reset is 0. So whatever there is in the previous state, that will be transferred here directly. Is it okay? So when both are 1, then it means so when both are 1, when both J and K are 1, so it will behave as a toggle state. That is why if the input Qn is 1, then the output Qn plus 1 will be 0. If the input Qn is 0, then the output will be 1. So here you can see it. Okay. So this is what, and this truth table has been that is This has been in short form. It has been represented in this way. That is, both are 0 and 0. Then you will be getting the output as qn. That is, what is qn? Whatever the previous state, that will be there. If 0 and 1, so then it means that set is 0. So you can see that the output is nothing but qn plus 1 is 0. Okay. So here you can see that 1 and 0. So here you can see that since j is 1, so the output will be 1. So whatever the j value is there, it will be transferred over here. For this j and k alternate, that is 0 and 1 and 1 and 0, the j value will be output. Okay. But when both are 0, whatever the previous value of qn will be there. But when both are 1, then it will behave as a toggle state. That is, it will go to the qn bar. So this is how this JK flip flop will be operating. So here I have given a brief description of what happens. Okay, what happens when see, for example, if you are really very clear with what I have told. So this is just a small explanation. That's it. So when j and k are 0 and when s are equal to 0, so you can see that from the truth table. So when the inputs j and k are 0, the output does not change. Is it right? So the output does not change. That is, whatever there is in the qn, that will be transferred to qn plus 1. Similarly, when j and k, for example, j equal to 1 and k equal to 0, there are two conditions. One is q equal to 0 and q bar equal to 1. The other condition is q equal to 1 and q bar equal to 0. So what is happening? So finally, you will be seeing that it will be setting s equal to 1 and s equal to 0 for this particular condition, and whereas here it will be setting as s equal to 0 and r equal to 0 for this particular condition. And finally, you will be seeing that the inputs j equal to 1 and k equal to 0, it makes q equal to 1, because j equal to 1, so it will be q equal to 1, that is, it will go to the set state. So this is the case 2 actually. So now we are moving on to case 3. You will see that that is when j equal to 0 and k equal to 1, you know that so from this truth table you will understand that j equal to 0, k equal to 1, q will be equal to 0, that is, it will be in the reset because j equal to 0. So what happens? So here you can see that when q equal to 0 and q bar equal to 1, j equal to 0 and k equal to 1, and because of which q equal to 0 and s equal to 0 and r equal to 0. So since because of which SR will be equal to 0, and so there is no change in output, so you will be getting q equal to 0 and q bar equal to 1. Similarly, when what happens when in this condition, that is q equal to 1 and q bar equal to 0, when j equal to 1 and k equal to 1, so q equal to 1 and s equal to 0 and r equal to 1. So from this we can understand that q will be equal to 0. So this is how it behaves. So finally, you will see that what happens when j and k are both are equal to 1. So it has to go to the toggle state. So if q equal to 0 and q bar equal to 1 and j equal to k equal to 1, q equal to 0, s equal to 1 and r equal to 0. So according to the truth table, and finally we will be setting that q equal to 1. So similarly, when q equal to 1 and q bar equal to 0, when j and k equal to 1 and q equal to 1 and s equal to 0. So from this truth table we will be understanding that q will be equal to 0. So from this we can understand that when both are equal to 1, it will behave as a toggle state. That is, a flip flop output will be in toggle state. That is, if qn equal to 0, then qn plus 1 will be equal to 1. If qn equal to 1, then qn plus 1 equal to 0. So this is how this JK flip flop is will work actually, and this is the most frequently used flip flops in most of the memory elements. Okay, so it is having a lot of advantages over the SR flip flop. So hence it is most frequently used flip flop in most of the memory elements. So thank you very much. I hope that I have given you a short video on JK flip flop, and for more details you can refer books. Okay. So in short, in this video I can post whatever things that is possible, and I am sure you would have understood with the truth table of JK flip flop as well as it's working. So if you really like this video, please give a like to this video, and if you have any doubts, please comment in the section, and if you want to share to someone who is eager to know the working of flip flop and other things, please share this video, and also please subscribe to this channel if you like the videos which I post. Thank you.